Hi friends, hope you are doing great. Today we are going to see Kubernetes engine concept. Before going to the Kubernetes engine concept, let's discuss about what is a container. So a container, we are going to discuss about the container. A container image is a lightweight standalone executable package of a piece of software that includes everything needed to run it: code, runtime, system, tools, system libraries, settings. It has container and it has Tomcat, Java, Debian example, and one more container we have SQL Server, .NET, Ubuntu, and next we are going to see about that. In this image, if you are seeing, we could have a bunch of containers running on top of the same operating system kernel. Each one of those containers effectively has its own little environment, executable files, as well as the entire runtime setup. Each one of those containers can be created by using software such as Docker. Docker can be thought of as build kind of tool which takes in our code and output as a container, which can be fed around and run its own sandbox. Containers differ from virtual machines. Individual containers are often in Docker file format. These containers tend to run in container cluster which is managed using software known as Kubernetes. So here we have the next in this image we have container and virtual machines. So container has application A, application B, application C, and VM it has like a, but it has first infrastructure and second it is in hypervisor, but in container it is in infrastructure, after that host OS, after that Docker. Now we are going to talk about these containers. So first left side containers and right side virtual machine. So first containers, our individual container lies Docker. Docker is an open platform to allow folks to build and run distributed applications in the form of containers. The Docker runs on top of the host operating system. This means that each individual containers does not abstract the operating system. Next we are going to talk about virtual machines. Each virtual machine has its applications and libraries. It also has guest operating system, and beneath each of the virtual machines lies the virtual machine monitor or hypervisor as it's known. This is a piece of software which would be created by company like VMware, for instance, which makes sure that one or more machines or virtual machines are able to run on the host machine and interact with the hardware in the other infrastructure. Compute engine instances are virtual machines. Container engine instances are container instances. Run container cluster, one supervising machine. This is running Kubernetes, that is known as master endpoint. Hadoop cluster manager, this would in touch with a number of individual container machines, each running containers and each talking, communicating with the masters using piece of software known as kubectl. In the world of Google Container Engine, that coordinating machines is known as master node. It runs as Kubernetes. Each of the other machine in the cluster is known as node instance. Each node instance has its own kubelet talking to the master and a top which runs pod. Inside each pod run multiple containers. Master talks to node instance which return contain pods, pods. Those pods contain the containers. We are going to talk about again what is difference between the containers and virtual machines. Containers virtualize the operating system. Docker was acting as a proxy between the container and the operating system. It is more portable. Container it is quick to boot and it is size tens of MBs. We are going to talk about the virtual machines. Virtualize the hardware. Every VM has its own operating system which talk to the hypervisor. That hypervisor or virtual machine monitor is in effect virtualizing or abstracting the hardware. It is less portable and it is slow to boot and its size of tens of GBs. Next, what a virtual machine? A virtual machine is just more heavyweight than containers because the VM OS is going to take significant amount of space and resources. Next, we are going to talk about what is container cluster, group of compute engine VM instances running Kubernetes. It is consist of one or more node instance, a managed Kubernetes master endpoint. Each of the compute options available is actually based on the same underlying infrastructure, which of course would come as no surprise. What is a node instances? Managed from the master, run the services which are support Docker containers which contain the actual code has been executed. Each node runs the Docker runtime and host and kubelet agent which manages the Docker containers and scheduled on the host. What is a master endpoint? Managed master also runs the Kubernetes API server, which services REST request, schedules part creation and deletion on worker nodes, autoscaling, synchronizes part information such as open ports and location. What is a node pool? It is useful for customizing instance profiles in your cluster, subset of machines within a cluster that all have the same configuration. We can also run multiple Kubernetes node versions on each node pool in our cluster. What is a container builder? So container builder, it is a piece of software. It is a tool that executes our container image built on Google Cloud Platform infrastructure. Basically, this is very similar to the creation of jar file or any other kind of metadata executable archive. It will import source code from bunch of different repositories that this could be cloud storage. Next, we are going to talk about what is a Kubernetes. It is an open source project. It runs anywhere. It is a container centric infrastructure founded by Google 2014. It also provides us flexibility. We can integrate different type of tools. It manages Kubernetes community, vendors, users, customers, contributors or users. Example, Google Citrix, Fujitsu, VMware. Kubernetes is an open source technology and everybody can use it. Kubernetes is a very good tool to automate the deployment and scheduling management of containerized applications. On the top of that, we are bringing our own experience to manage our clusters, and we do all of that on the top of GCP with the best network persist disk, amazing performance, and such features on GCP. This provides for us to the best platform to manage our application instead of focusing on the machine and the infrastructure. Then why do we need a Google container engine? So first of all, yes, it is still Kubernetes. It is pure Kubernetes. It is easy and powerful managed clusters oriented container service, performance, scale and efficiency of GCP. It is managed application, not a machines. Next, we are going to talk about few topics, few concepts in Kubernetes engine. So Kubernetes, it is a container orchestration system, as I already told. Kubernetes engine is a managed Kubernetes service. Kubernetes is an open source platform developed by Google and now widely used for deploying containerized application. Kubernetes is deployed on clusters of servers. We could run our own Kubernetes cluster by deploying it to VM in compute engine, but then we would have to take on the responsibility for operating the cluster. With Kubernetes engine, Google maintains the cluster and assumes responsibility for installing and configuring the Kubernetes platform on the cluster. Kubernetes engine deploys Kubernetes on managed instance group. One of the advantage of Kubernetes is that users can precisely tune the allocation of cluster resources to each container. This is especially useful when applications are designed as a set of microservices. For example, a microservice might need only a small fraction of a CPU. In that case, a container running that microservice can be allocated only the amount of CPU needed. This allows for more efficient use of compute resources. Alternatively, if the microservice were deployed on a VM with a full virtual CPU, the virtual CPU would be unutilized. It leaves developers with the choice of either tolerating inefficient utilization or running additional microservices on the same VM. This approach has its own disadvantages. Unless all microservices have the same life cycle, we may find that performing maintenance on one microservice can disrupt the operations of the other microservices. By separating applications components into microservices and running those microservices in their own containers, we can improve resources utilization and possibly make the applications easier to maintain and update. Another advantage of Kubernetes it is that it can run in multiple environment including other cloud provider and in on-premises data center. Kubernetes can detect when containers within pods are not functioning correctly and replace them. Kubernetes can also scale up and down the number of pods to accommodate changing workloads. Perhaps the most significant constraint of Kubernetes is that applications must be containerized to run on Kubernetes. If existing applications running on-premises in VMs are migrating to the cloud, a lift and shift migration in which the system architecture is not changed to compute engine is likely the fastest way to get to the cloud. Once three, once there we can containerize our application. Next, we are going to talk about what is cluster architecture. What is a cluster? A cluster it is the foundation of Google Kubernetes engine. The Kubernetes objects that represent our containerized application all run on the top of the clusters. Next, we are going to talk about control plane. What is a control plane? The control plane runs the control plane processes including the Kubernetes API server, scheduler, and core resource controller. Next, what is a nodes? A Kubernetes cluster consists of a set of worker machines called nodes that run containerized applications. Every cluster has at least one worker node. Next, what is a pod? So, pods are the smallest, most basic deployable objects in Kubernetes. A pod represents a single instance of a running process in our cluster. Pods contain one or more containers, such as Docker containers. When a pod runs multiple containers, the containers are managed as a single entity and share the pod's resources. Generally, running multiple containers in a single pod in an advanced use case. When we run kubectl get pod to inspect a pod running on our cluster, a pod can be in one of the following possible phases: pending, running, succeeded, failed, unknown. Next, we are going to talk about kubectl. Kubectl, the Kubernetes command line tool. It is a Kubernetes command line tool, kubectl. Kubectl allows us to run commands against Kubernetes clusters. We can use kubectl to deploy applications, inspect and manage clusters resources and view logs. Kubectl is installable on a variety of Linux platform, macOS and Windows. An agent that runs on each node in the cluster, it makes sure that containers are running in a pod. The kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubelet does not manage containers which were not created by Kubernetes. A node instance. What is a node instance? It is a model element that represents an instantiation or actual occurrence of a node. Node instances are based on existing nodes, while a node represents a generic type of computational device. A node instance represents a specific and defined node in our system environment. Kubernetes provides a managed environment for deploying, managing, and scaling our containerized application by using the Google infrastructure. The Kubernetes engine environment consists of multiple machines, specifically compute engine instances, grouped to form a container cluster. Thanks a lot, friends. We have done with the Google Kubernetes concept today. In our upcoming video, we are going to see the Google Kubernetes engine demo. Thanks a lot. Have a great day. Bye.